Hello students. Today we're going to discuss 4 ways to represent a function. Our goal is to just get a little bit more comfortable with functions and the ways that they can be represented. So far, we have looked at one way to represent a function. Specifically, we've looked at representing functions algebraically. And what that means is with an explicit equation that describes the function. For example, we might have f of x equals x squared minus 4. That is a function, but there are 3 other ways that we can represent a function as well. Let's take a look at these other ways and adapt this function to represent them using the other ways. The next way that we can talk about a function is verbally. We can describe a function in words instead of just an equation. So if we want to talk about this same function f, we can say what f does. F squares the input because it takes x and gives us x squared. So it squares the input, and then what happens next? Subtracts 4. So what this function actually does to the input x is it squares that value, and then it subtracts 4, or it takes away 4. And so we could say that verbally. F squares the input, or we could even say f squares x, or f takes x and squares it, and then subtracts 4. There's lots of ways that you could say this. If we had 35 students each write this out verbally, I would imagine there'd be at least 15 different sentences that were still correct. We're just using slightly different words or word orders because English is a little bit of a flexible language like that. All right? So just because 2 people have written it using slightly different words doesn't mean necessarily that one person is wrong. So we can do that verbally. We can also express it numerically. And one way that we can do that is with a table of values. We can list the x and y values. Not all of them, because there are an infinite number, but we can list some of them, and that gives us a numerical representation of this function. We could use -2, -1, 0, 1, and 2, for example. Let's see, -2 squared minus 4. -2 squared is 4, and 4 minus 4 is 0. I'm just doing this quickly in my head. -1 squared is 1. 1 minus 4 is -3. 0 squared is 0. 0 minus 4 is -4. 1 squared is 1. Minus 4 is -3. 2 squared is 4. 4 minus 4 is 0. So this is a way that we can represent this relationship numerically. Now, in this case, I would say that representing it numerically is probably not a very good way because there are really an infinite number of x values that we could choose and an infinite number of corresponding y values. This doesn't really represent the whole function, only a few points. But sometimes we have a function that is not defined for every single value of x. It might just take a few different values of x and give us values of y. So there are situations where that might end up making sense or being useful. And then the last way that we can represent a function is visually. And specifically, we can do that with a graph. If we plot these points on the xy plane, -2, 0, -1, -3, 0, -4, 1, -3, 2, 0, etc. We know this is going to be a parabola. It's a second-degree polynomial. We end up with a graph like that. Y equals x squared minus 4. So these are 4 different ways that we can represent the same relationship. We've got algebraically via an explicit formula. We have verbally with a verbal description that tells what's going on. Numerically, we've got a table of values that says what's going on. And then visually, we have a graph. All of these are different ways to represent the same function. In the next video, I'm going to look at a few more examples of functions represented in different ways so that we can get practice identifying different situations that are functions and also get comfortable with functions that might be better represented in one way or another.